So this is my annual GNU Radio project update, nominally kind of our State of the Union. So anyone who's seen this before, at least for the last 3 years, is used to me yelling at all of you for waiting until the very last minute to book your tickets. So I made this chart about maybe 2 weeks ago. And you can see it was just below 300 then. I was looking at this, I was like, this isn't so bad. I mean, it's not like the flat thing and then the exponential spike, right, that we usually see where I'm worried about the solvency of the conference and that kind of thing. But in the last week, that has spiked to way up above 350. I just didn't have time to make a new chart because all of you registered so late. So I might just give up at this point and accept that we somehow have to forward pay for GRCon before getting money from any of you. But thank you all for being here. So I'm going to kick this right off with the big news. 3.8 is finally out. So huge thanks to the core development community. Marcus Mueller and Andre and Martin and everyone that serves in an officer position of the project worked extremely hard over the last year to make this happen. You might have noticed that the 3.8 release announcement came out extremely early in the morning, German time. I realize there's more than one time zone in Germany. I apologize. But yeah, this was a lot of work. So there were more than 200 contributors in the changelog for 3.8. And we went and thought, OK, what does that mean? How many projects not just have 200 contributors, but have 200 active contributors? And there's not many. There's not many. GNU Radio is very legitimately up at the top in terms of community engagement and participation and the type of people and the breadth of people that are participating. It is also good that we did this since Python 2.7 is no longer supported in less than 3 months now, I think. And our 3.8 release was the Python 3 migration. So we kind of got by the skin of our teeth there. So one of the things that was interesting about releasing 3.8 is the news got picked up in a lot of places that we'd never heard of before. Here's a few examples. This website, Packet, had a whole thing on it. Oh, now, lwn.net, I'm sure everybody's familiar with, but they had a big piece on it. We hit the front page of Hacker News. I don't really care for that website at all, but it was interesting to see a GNU Radio release announcement be on the front page of Hacker News with a whole bunch of people commenting on it. We made several print magazines. So this is a picture from Derek of the Radio Society of Great Britain's magazine, where they sort of copy and pasted chunks of the changelog in ways that don't make any sense into the magazine. They did it in a way that's not all that great. It's the first sentence is it's their first release in 6 years, and the next sentence is a bunch of code stuff. So I don't know that it made us look all that good, but we got a lot of attention for this. It was really cool. One of the things that we've gotten the most comments on is that, yes, it finally has squiggly lines. James, are you in the audience? No? Of course the examples just worked, James. Did you expect something different? So one major note here is your out-of-tree modules probably have to be ported. So if you are an out-of-tree maintainer, please get your stuff ported. Bastian Blossel actually wrote an excellent guide for how to do this that works really well. It's not a huge challenge. Most of the problems are really the Python 2.7 to Python 3, assuming your blocks are written in Python. But the porting guide is pretty straightforward. So this is my yearly stats slide. Participation is way, way up. You can see the numbers for CLAs, issues, and pull requests. Now this is kind of, this isn't a full view, right? Because a lot of the community does not interact with GNU Radio through GitHub. And so most of these numbers are through GitHub. But enough of the community interacts with it that kind of gives you some idea of the overall growth, right? So you can see we're at 1,100 here when I pulled this chart, 1,100 unique cloners per 2-week period, just from GitHub alone. That's up by several hundred from last year. Our executed CLAs are up 155%. We're up almost 60% in year-over-year closed issues. And pull requests went from 272 to 443. So participation is accelerating. We once again participated in Summer of Code programs. So we actually did not participate in the ESA's Summer of Code program this year, but Daniel Estevez did and had a student work with GNU Radio. And actually, he has a poster here, and Daniel has a keynote later this week. Our 2 Summer of Code projects were a block header parsing tool, which will auto-parse your block's source code header and produce a GRC YAML file. And then Bound, who should be here, are you in the audience? Hey, I'm so glad you made it. Bound had a very long way to travel to get here. He created a cycle-accurate simulation of Verilog files from GRC. So if you have a Verilog file, you can drop it in using his code and actually get Verilog simulation from within your flow graph. They both have posters in the expo. Bound's here to present his. And if you have questions about Arpit's work, you can talk to Nicholas. And I want to give a really big thanks to Felix for once again running GSOC. It is a lot of work in terms of managing the overall program, working with Google, managing the movement of funds. It's not an insignificant task. So thank you very much, Felix. So technically, we ran this last year. The reason I'm going to talk about it now is we want to do another one shortly. So last year, we released several SIGMF recordings containing some hidden messages and just kind of threw them out in the community and wanted to see how much interest there was. And it turns out there was a lot of interest. We got participation from all over the world. Our winners were from the US, France, Hungary, Slovakia, and the Netherlands. The challenges themselves were built with RDS and some simulated NOAA downlinks. But this was really exciting, and people got really, really into it. So we're planning to do another one of these. And the goal is to have it have a breadth of challenge levels. So ones that are doable and solvable by people who are perhaps new, and some that are really difficult. So keep an eye out for this. We should have an announcement somewhat soon about this. One of the big things we did this year was the SETI Institute sponsored and hosted a hackathon at the Allen Telescope Array in Hat Creek, California. We've had a lot of hackathons over the years. This is probably one of my favorites. So we had over 30 attendees from industry, government, academia, and hobbyists. And it attracted a lot of people who otherwise had not participated in the community. So the key areas of development there were SIGMF, GNU Radio blocks for actually working with and on the Allen Telescope Array, which Mike Piscopo did. Mike's here, and he is running the SDR for Space Signals workshop tomorrow. GNU Radio for radio astronomy, and I'll talk about that more in just a second. Antenna array monitoring and health from GNU Radio, and machine learning for signals detection and classification. So one of the really cool things that came out of this, there was a lot, but one of them that I want to highlight now, Nick Foster produced flow graphs for actually processing signals from Voyager. So the SETI Institute has been publishing SIGMF recordings from the Allen Telescope Array and Green Bank. And so you can go download those and then use Nick Foster's flow graphs to play with Voyager signals from GNU Radio. And these slides will go live, so if you don't want to try to type those URLs real quickly, you can click the links. And I had to include this picture because it really was beautiful there. It was phenomenal. So I'm going to go through just a couple other things that generally happen that people might not be aware of. So there is a conference hosted by Enzo Leon in the EU every year called EU GNU Radio Days. This was its second year, and it more than doubled in size. So this is pretty quickly becoming sort of an EU version of GRCon. This year it was in, no chance I'm going to pronounce that correctly, Besançon, France. They have already announced for next year in, again, I'm not going to know how to pronounce this, Poitiers? Somebody help me? France. So it is always in June. This year, Marcus Mueller keynoted. We had a bunch of other people fly in from the GNU Radio leadership. It's, you might recognize some of the sponsor names here, especially Analog Devices and Roden Schwartz. They have really, really interesting content, and they have a lot of participation from the EU academic community. So I recommend making the trip if you can do it. There's also the SDR Academy. So this was its 5th year. It's organized by one professor from Germany and one professor from the UK. And you can see one of their top requested topics are advances in GNU radio-related research and projects. So this is a one-day event. So it can be, if you're based in the US, it can be hard to make the trip out for a one-day event. But if you're looking for an excuse to go to Germany, this particular event is specifically geared to be like a learning experience, right? It's called an academy specifically because it's supposed to be an educational experience. So this kind of leads me to what I'm going to spend most of my time here talking about, which is the GNU Radio community itself. And so every year, I kind of spend like 10 minutes of this talk sort of highlighting major things that have happened around the GNU Radio community that some of you may or may not have heard about. One of the things I really want to try to get across this year is just the incredible breadth of everything that's happening in and around GNU Radio all the time. All the time. And so I use the word community a lot. It's kind of ambiguous, right? Is community the developer community? Is it the people who come to GRCon? Is it the community on the mailing list, right? In reality, the community that most of us know is a tiny microcosm of everything that's happening in GNU Radio. Our best guess is the mailing list is somewhere less than 5% of users. GRCon is way less than 1%. There are things happening constantly. So what I've done is I have gone back over the year and tried to pull a lot of really neat things that I saw on Twitter, just on Twitter, about things that are happening. So just one example, there are classes that are taught all the time and events happening all the time that people from GNU Radio attend or even teach. So on the left is an image from a GNU Radio tutorial workshop taught by Derek in Belgium. On the right is a picture of the Chaos Communications Camp in Germany, which was just a couple weeks ago. GNU Radio was hosted by Stratum Zero. This is, so NSF is running a program called Power, where they're building city-scale testbeds. Like literally, they're collaborations between universities and the city, and the university goes out and deploys SDR testbeds over the city, like putting them on buildings, and making a testbed that people can use for scientific research. Powder is one of them. It's in Salt Lake City, so it's a collaboration between Salt Lake and the University of Utah. Using hardware from Rice University, they built the Powder testbed. They're running GNU Radio tutorials in Salt Lake City pretty constantly, actually. These are really cool tweets from Kees Pasa. So Kees works at the Institute for Astronomy in the Netherlands, and he volunteers at the Dwingelu was, thank you, Paul. Was that Paul? Yeah, thanks. At the Dwingelu telescope. So Paul is, actually, a major part of that, is giving a talk on Thursday about this work. And Daniel Estevez is also a major part of this. But I'm going to highlight these tweets from Kees just because they're so cool. So you might have heard that of the DSLWPB, which was the lunar orbiter that NASA flew into crashed into the surface of the moon, right? He observed that from the telescope, and you can see here on the left the GNU Radio flow graph running, and sort of live tweeted this happening as he was making these observations off the telescope, and then as the orbiter crashed into the moon. And you can see on the right where he determined that it had in fact crashed, and there was a crater on the moon. This happened again just a few weeks ago with the Indian Vikram lander, where he was live tweeting and tracking the Vikram lander as it attempted to land on the moon and unfortunately crashed. You can see on the right here where things kind of go awry. And I think he was actually, I looked elsewhere for someone to have determined that the Vikram lander had crashed before this, and I couldn't find it. I think this was the first sort of like public evidence that the Vikram lander had failed to land. So I found this one. So this was a Chinese satellite that took off, and I have no idea. By the way, I have no idea who most people in these tweets are. I found this one. He basically reverse engineered and demodulated this satellite downlink using GNU flow graphs and posted all the flow graphs and the data recorded from them, just for fun. SatNogs continues to be amazing. So we had a SatNogs keynote last year, which was awesome. And now they have all kinds of neat stuff happening in their community, like people building these touchscreen stations to run their SatNogs ground stations, which is, of course, using GNU Radio behind the hood. This is one of my favorites. This is Alexandru, who wrote GQRX, who toured the ESA's CubeSat ground station during the CubeSat workshop. And the ESA asked, perhaps some of you know this software, which was the software that Alexandru had wrote. So we got a picture of him sitting next to the ground station running gpredict and GQRX. So phase 4 ground continues to move quickly. You might have, if you were here last year, you would have seen a presentation from Michelle Thompson about that, who's one of the GRCon organizers, and she ran the block party last year for building block decoders. And there's a lot of work happening around here for satellite downlink decoding, especially from Ron Economos, who his working name is Dr. Impeg. So all of the DVB stuff, DVB anything, that exists in the open source world has probably come from Ron. So DVB-T, T2, S2, S2X, he's written all of those decoders. And he continues to push that forward as part of the phase 4 effort. Now, what's really cool about this kind of thing is, like, once you're sort of tuned into this, you start seeing it pop up everywhere. So as an example, I saw this Wired headline about, this is a DEF CON talk this year, watching a drone take over a smart TV. The idea here is smart TVs, well, the hack that was being shown was that smart TVs have absolutely no authentication and do not care at all where signals come from. And so he stuck a Raspberry Pi on a drone and flew it over somebody's house, and a prompt on the smart TV came up and said, please give me your Wi-Fi password, and you need to reconnect to the network, and it looks totally legitimate. And as I was watching the YouTube video, it kind of pans right to the laptop, and you can see him running the Ron's DVB utils for this work. So the stuff is everywhere. And there's very clearly a space theme to these, by the way, just because we're here. There's a lot more that's not space themed. So these are interesting. So on the left is somebody who's tweeting about having built their CubeSat ground station with a HackRF. So this is not just receive, this is transmit and receive. On the right, so I actually edited this slide this morning to add the one on the right. This tweet went out last night about this person took GR LilacSat and modified it and are now decoding Taurus-1 telemetry, which I think is a Chinese satellite that's now somehow part of AMSAT in some way. I don't actually know what Taurus-1 is. I tried to look it up and got confused. So there's now a LibreSpace has produced a SATCOM channel simulator, which is really cool. So this was a joint initiative from ESA and LibreSpace that came out of Makerspace. And so you can fully simulate SATCOM channels from GNU Radio now. I thought these were really, really neat. So on the left, I'm not really sure what that thing on the left is. It's clearly some tiny little ARM-based board, I'm assuming. But they got GQRX running on it with an RTL. On the right is a Nintendo Switch. So this one's kind of cool. This is actually, it's an RTL dongle that's running somewhere else and streaming samples to the Switch over Wi-Fi, and then they have GQRX running on the Switch. Which is really, I have no idea who this person, Spectrophagus, are you in the audience? No? So whoever they are, they tweet really cool stuff pretty regularly with GNU Radio. I haven't a clue where they are or who they are. But this was really neat. He said that the next thing he wanted to do was, the other thing that he started working on was trying to get phosphor running on the switch, accelerated by the graphics card. This is some cybersecurity stuff, right? On the left is Holly Graceful, basically doing some playback attacks for fun. On the right, so there's actually pretty regularly, I'll go into this a little bit more later, there's pretty regularly courses given and tutorials written about using GNU Radio for cybersecurity. We almost never hear from the people doing this, which is, which is interesting, but that has especially exploded in the last 2 years, especially with the success of the HackRF from Great Scott Gadgets and the explosion of the RTL dongle. It's made RF way more accessible to the cybersecurity community, which perhaps didn't previously have the radio background to have been successful with it. And I have some more slides about that in a minute. One thing I do want to kind of highlight here, so GRGSM hit the news again. So if everybody's familiar with GRGSM, it's been around since about 2014. And on the left, so there was an article written by Vice, where the Vice journalist made an IMSI catcher with GRGSM in 30 minutes and wrote an article about it. And so that then, of course, exploded, and it got captured on the right by Cory Doctorow, his blog, Boing Boing, and that spread really quickly, which is kind of interesting because I think actually we haven't really worked with GRGSM in a little while, but it's kind of an indicator of how the GNU Radio community tends to push things forward really quickly, often before sort of everyone else that might be interested in it realizes what's happening. And then we see this effect where like 5 years later, people are like, oh my gosh, like this happened, and it hits the news and spreads everywhere. This was kind of like, right, 2 years ago when the Daily Mail published an article about stealing cars with HackRFs, right? We see this pretty commonly. Again, cybersecurity courses, there's GNU Radio-based cybersecurity courses that get taught at tons of conferences. I just grabbed these as quick examples. This one's from B-Sides. The one on the right's from Black Hat. The one on the bottom is actually an online course that was written by Bastion. There's actually several textbook series now that have been released that teach cybersecurity with GNU Radio. The person who wrote those in the audience? No, I don't know who they are. I really liked this one. So this is Dominic Spill's Ridiculous Radios. They got featured on Hackaday. So he builds SDRs out of random parts. The one on the right is built out of parts from a VCR that interfaces, and you can see it. You probably, I don't know if it's too washed out. You can see GNU Radio flow graphs running in that image there. So we also continue to see an expansion in education and curriculum development. So this happens, again, this kind of thing happens all the time, and I feel like we only see like bits and pieces of it. So Dan Kajacob, I'm not actually sure how Dan spotted this. Stuttgart tweeted that they were phasing GNU Radio into some of their courses, and Dan caught it, and so I reached out to the professor, and it turns out they're making GNU Radio the core of their signal processing, radio, wireless communications curriculum at the undergrad and graduate levels, and rolling out an entire curriculum for it starting next year. And this kind of thing happens all the time. It's just that the professors who have done this are not here. We don't necessarily hear from them. So what I'm really trying to communicate is this community, to again sort of overuse the term, is huge. And there's just constant motion and constant development. And I think we only really see a very small part of that. And I think it speaks to the strength of what we built. So real quickly, to go through some expansions and growth in hardware support. So SignalHound announced GNU Radio blocks last year, which was really cool. RTL SDR has basically chained four RTL dongles together and called it the Kerberos SDR, and has made that. It's specifically geared for direction finding. ADI is working through the grep process to upstream GRIIO into GNU Radio, which uses the Linux kernel's industrial I/O module for data movement. If you want to get involved in this grep because you care about data movement on embedded devices, go do it. We're really, really excited about this. There's Kiwi SDR, which is a low-cost SDR built specifically for geolocation. DeepWave's GR Wave Learner, which is built specifically to facilitate performing inference or machine learning within GNU radio flow graphs. This is one I just saw this morning, actually. Hermes Lite 2, which has been designed to be a low-cost HF design. It actually uses the 809866, which is a cable modem from ADI as the codec. But it's that particular part is produced in such quantities that this is going to be extremely cheap. So I'm highlighting this one, the Tuha, I'm not actually sure how they pronounce it, SDR, because Alban Stigo is one of the developers of this board. So this is an FPGA-based SDR that's being built to be a Raspberry Pi accessory board. I'm going to talk about Volk in a second, but there's been tremendous movement in Volk recently, and a lot of that is happening because of this SDR. So with that, let's talk about Volk and SIGINT. For anyone who's not familiar with Volk, Volk is the vector-optimized library of kernels. It is our way of doing SIMD, single instruction multiple data, operations to accelerate flow graphs. And then SIGINT is, and I have a talk on this later, but SIGINT is a way to create data recordings and then share them and process them. So Volk has seen a lot of development in the last 6 months, especially on ARM devices and especially on the Raspberry Pi. So if you have not tried running GNU Radio on the Raspberry Pi recently, and that's something you care about, you should give it a shot. Alban has been on a roll and has been committing kernels and making improvements on an almost weekly basis. We're very lucky to have Alban participating. He's actually an anesthesiologist in Sweden that just does this for fun. And the guy is pumping out SIMD optimized kernels at a rate that's incredible. I don't know how it's not his full-time job. It's amazing. So SIGINT has also expanded significantly in the last year. One of the interesting things that we've seen about SIGINT's expansion is that it's mostly silent. Most of the people that are using SIGINT don't actually tell us that they're doing it. And I sort of just pick up these bits and pieces of things, or somebody will send me a statement of work piece from a company or a government or something like that, and it is demanding that everything be delivered in SIGINT. So SIGINT is sort of silently taking over the sharing of RF data. So we spent a full week at the SETI Hackfest working on the SIGINT design. A core group of us did. I'm going to talk a lot more about SIGINT when I talk on Wednesday, but not everyone is going to be there because my talk is after lunch, so there's going to be the workshop split. So the one thing I want to make clear to everybody, if you're not going to be in the talk, is that it's become clear that the current design of SIGINT is really good at what it does, but that it can do a lot more if we make some non-backwards compatible changes. And the direction we're going to take it specifically is to try to answer the question, how can you record data and describe it and such that another program, another computer, can understand those descriptions without a human ever being involved? And we've made really good progress on this, but it's going to break backwards compatibility. So going forward, we're going to take the existing SIGINT structure, clean it up, close the remaining issues, basically put that into maintenance mode, bug fixes only. And from there, the new development branch will break backwards compatibility. But this is the direction we're going. And we have good momentum to get there. So I couldn't talk about SIGINT and not talk about, knowing that I was going to build this presentation with mostly tweets, I tweeted last week and said, if you have a favorite GNU Radio tweet, send it to me now. I might include it. The one that I got back a lot was actually mine, but not perhaps in the way you might think. So I thought I was being clever. We just got my DeepSafe. We just moved to a very high-rise in Arlington that overlooks DC. So I thought I was being all clever and taking pictures of my B200. connected to this antenna overlooking DC. Probably can't see it. That's the Washington Monument. This is Georgetown, right? These are pictures on the right. This is a picture of Arlington. So, the antenna pointed back over like Roslyn and Ballston and Courthouse, and those areas. This is so cool, right? And then I got dunked on harder than I've ever been dunked on in my life when UC Berkeley tweeted their collaboration of radio telescopes. And then to make it worse, this was NVIDIA's response. Thank you, NVIDIA. So on that note, I want to talk a little bit about SETI. We're really excited to announce that SETI is co-sponsoring, specifically the SETI Institute is co-sponsoring GRCon20. So you might remember the SETI Institute delivered a keynote last year. Our collaboration with them has grown substantially in the last year. There is a lot of overlap in our joint goals and the things that we value and the things that we want to achieve, both in terms of technology direction and education. And we're really excited about the way this is developing. So just to answer a few questions about, wait, I thought SETI was just aliens. SETI is actually a much larger program. What most people are familiar with is SETI RF. That's the thing on the right, which is detecting aliens with the giant array that we had the hackathon at, that the movie Cosmos was about, right? Not Cosmos, sorry, Contact. Confusing my Carl Sagan writings. They have a lot of stuff in many, many different areas. And it's a pretty significant research institution. They're partners on a bunch of NASA missions. They have a significant sort of worldwide network of telescopes that we can get access to. Now, all of the telescopes, the Allen Telescope Array is the only array that is allowed to track human-made objects. All the other arrays can be used to track anything else. And they have a really interesting mix of funding sources and partners, some of whom you might recognize from the GNU radio community. Others are new. So we're really excited about the direction this is going and are looking forward to working with them on GRCon20. And Steve Croft, are you here, Steve? No? No? Oh, sorry, Croft, not Conklin. Sorry, Dr. Steve Croft will be here. He's actually giving a talk tomorrow or Wednesday. Okay, so I want to talk a little bit about GRCon. First, I want to give a huge thanks to the GRCon19 team, especially Michelle and Steve and Derek. So if you could just get a round of applause for them. So it is hard to communicate how much effort it takes to make this thing work. Even with all the stuff that's gone wrong, like you don't have power strips, right, and the registration took too long, it's taken thousands of hours, I'm not exaggerating, thousands of hours to make this happen, and we do it every year. And this is all volunteer time, right? So Michelle and Steve and Derek Michelle and Steve are co-chaired it, and Derek has poured tons of time into this, have really made this possible. And there's a lot of other people that contributed. Neil Pandya of Edis Research, Sam of MITRE, Tathagata, who is a professor at UAH. There's a lot of students here. He was involved early with the idea of coming to Huntsville. There's a lot that goes into making this thing work. And none of these people are paid to do it, and they spend the entire year working on it. So GRCon 2020, we are almost definitely headed to Charlotte, North Carolina. I say almost definitely because we have not actually executed the venue contract that we have, but we're probably going to Charlotte. And until we have a venue, can't guarantee dates, but for the last 5 years, we've been this week of September, so probably this week of September. If you're interested in getting involved, please reach out. You don't have to spend thousands of hours, right? Every little bit helps. So if you think you just have a couple hours every other week, right, even that helps. So if you'd like to get involved, please just shoot us an email, grcon@gnradio.org. So what I want to use the remainder of my time to talk about is project direction. So each year I've kind of had a theme, right, or like a question posed. In 2017, the question I asked was, have we hit P1 dB? Right, it was, GNU Radio was at that point, 16 years old. It had expanded significantly. And the question was, okay, what do we do from here? Have we hit P1 dB, and is growth going to start to sort of level off? Or in my belief was, if we double down on this, this is going to explode into something even bigger. So I think that very definitively the answer was, nope, we didn't. We definitely did not hit P1 dB. If anything, things have accelerated. And now we see our understanding of GNU Radio has evolved. Right? We used to think of it as GNU Radio is the project, like it includes like Volk and SigmaF, but everything that we all think of as GNU Radio, right? But it's really so much more than that. It's an umbrella of lots of different work. It's a collaboration of universities and industry and business, most of whom we never hear from, right? It's much broader. I think we're coming to understand just how strong and how large the footprint is. So in 2018, I asked, how do we address sustainability? So since last year, a lot of really good things have happened here. The thing that I was most worried about last year was effectively financial support for people to work full-time on GNU Radio. We've had several good conversations that came out of this, and things are actually looking really good. We have sponsors that have stepped forward to help fund GNU Radio R&D, and we have things in the pipeline now for actual revenue-generating programs. There's work to be done on a more stable organizational solution, but things are really, really good here. I'm not worried about this. So what's my question for this year? I think it's time that we start looking at the GNU Radio runtime. So GNU Radio is 18 years old, so it's almost 2 decades. I want to say the fact that a scheduler that was written in 2001 has made it through 2 decades of SDR work is incredible. That's a feat of computer science. But I think it's time for us to start talking about what comes next. Things are changed. Things have changed a lot, right? In 2001, everyone thought Moore's law was still the thing, right? That's what you would think about was Moore's law, right? I think everyone knows now that Moore's law is dead. So in the leadership community, we've been talking about this as GNU Radio 4.0. So that's not meant to be a joke, right? We're at GNU Radio 3.8, planning for 4.0, where that would be a new runtime release. So it's clear now that moving forward, the future is heterogeneous, it's parallel, and machine learning is going to play a huge role. And there's also just the fields of computer science and software engineering have advanced significantly in the last 20 years. Everything like developer experience and dependency management, how you deal with client-server designs in the cloud and local nodes, how you can instrument and debug complex systems. The world has come a long way. And I think it's time for us to circle back around and think about, OK, how do we make a GNU Radio scheduler that's going to last us the next 20 years? So we're not under any illusions. This is going to be a very substantial undertaking. It's going to take years of effort from a strong team. And this week, one of the things that we really want to be discussing is the organization and planning of this. So I think we're at the point of asking the question, what do we need to know? Like, I don't think we know all of the things we don't know yet. So that's what we're trying to figure out, is what do we need to know in order to figure out how to do this. So if you have thoughts about this, if you care deeply about this, if you have been thinking about this, come talk to me. Come talk to anybody that's active. We want to figure out how to do this right. Realistically, this is going to be 2 to 3 years of work, and we want to make sure the thing that we produce is going to last us another 20 years. So I'm going to end this just with a few other bits. So one of the things we're talking about is the idea of offering SDR office hours. So this would be GNU Radio developers effectively offering mentoring or one-on-one office hours for people who are either new to SDR or know SDR and are new to contributing to open source. So we're running a survey to gauge interest and gather feedback. This got a bunch of press, actually, about a month ago. and there's been a lot of responses. But I don't actually know that it got a lot of attention from sort of the community that comes here. So I want to highlight this. That URL is an L after the 2. That's 2L, S-E-U-R-Z. If you're interested in being a mentee, or you know somebody who might want to be a mentee, or you're interested in being a mentor, please fill this out. Just to be clear, we don't know that we're going to do this. It represents a significant time investment, but I think it's a way to expand the community, help educate people that want to get involved but perhaps don't know where to get started, because let's be honest, SDR can be really hard. The last thing I want to say is I'm giving an open source licensing talk tomorrow. So I've made this survey. It is a 5-question survey. I suspect it's going to be very easy for some of you, but perhaps very difficult in ways you didn't anticipate. It should only take a couple minutes, and what I want to do is show the results of this sort of questionnaire at the start of the talk. And the goal is to just try to gauge how well do we actually understand the way open source licenses work. So this again is an L. It's 2L WTGXK. So please fill it out, and I'll share the results at the beginning of my talk. So with that, are there any questions?
Do we have a good sense of how many people understand the runtime right now? And if it's really small, do you think a good step might be to focus on broadening that knowledge base?
Yeah. How many people understand the runtime? So there are probably a half a dozen that really, really deeply understand it. And I'd say probably a dozen more that understand how it works, but perhaps not why it was designed the way it was. So altogether, I'd put it somewhere between 15 and 20 of people who could really contribute to that conversation.
That's more than I thought.
Yeah, I mean, it's pretty. So for example, the keynote that Marcus Mueller gave at EU GNU Radio Days this year was on the runtime internals and how it was designed and works. So I think we have. I agree. It's actually. I did not think we had as many people either. I sort of sat down and went through it. It's actually pretty sizable. Yeah. What's up, Dan? Sorry, we're supposed to have 2 floater mics. We're waiting for the venue to give us a second.
Thanks. Is there a big release between 3.8 and the scheduler change?
We have not specifically planned for that, but we're talking about the scheduler change as 4.0 to allow for that release prior to swapping out the scheduler. And I should say, right, one of the most difficult parts of the conversation about changing the runtime is, so we have 20 years of application code, right? That's immensely valuable, right? I mean, that's really where the value, if you're going to talk about the value of the code, that's really where the value is in all of the modules that have been written around GNU Radio, right? Plus, the scheduler does work. It just works, right? So we have to find the balance between the incredible value of everything that we have and not being, I think, constrained by the design concepts of 20 years ago. Where that balance is, I'm not sure. Like that, I think that's what we're trying to figure out is how much do we want to maintain and value what we have now versus breaking it for something better? How good does better have to be in order to do that? I don't know. I mean, maybe the answer is we don't. We maintain backwards compatibility for absolutely everything, and we have translation layers, right? I don't know. What's up, Marcus?
So I do happen to have a talk about exactly what the plans are on this for tomorrow, so yeah, come and see me. Also, I didn't do my slides, so this is good input. Thank you.
Other questions? No? Okay, fantastic. Thanks so much, everybody. Oh, so